Hi, I'm Felix. I'm from Munich, Germany. And today I will talk about the impact of Stack Overflow on Android application security. And this is a joint work of Fraunhofer Isaac and CISPA Saarland University. So when it comes, so Stack Overflow and Android applications really haven't been the best friends when it comes to code security. As anecdotes report, you can go to Stack Overflow and find insecure code snippets, which probably have been copied and pasted into a lot of Android apps. And this is something we have already known or assumed for 5 years now. And it all started in 2012, where we found a lot of Android apps that implemented insecure server authentication during TLS handshake. And that cryptographic misuse was a huge issue, as well as certificate pinning, which was either rarely applied or flawed. So for each of these issues, you actually can find, oh, my slides are gone. Okay. For each of these issues, you can actually go to Stack Overflow and search a little bit, and you can find examples for this. So consequently, Yasmin asked last year, what is the prevalent information source developers use while implementing security, and mainly when they got stuck implementing security. Security is getting too complex. And the answer to this was Stack Overflow. And during that lab study where developers implemented security, it also has been observed that, that developers copy and paste code snippets, even if they're insecure. So that is why we asked this year, what really is the impact of copying and pasting code snippets from Stack Overflow on Android application security? And we do this by analyzing the flow of security-related code snippets from Stack Overflow into Android applications available on Google Play. And to achieve this, we first filtered the security-related code snippets from Stack Overflow to be able to then analyze their security by classifying them as secure or insecure, meaning bad or good examples. And finally, we detect their reuse in Android applications. And after that, we provide a community feedback analysis on insecure snippets we actually have found in Android applications to see if the community feedback is preventing or contributing to copy and pasting insecure code. And each of these steps for each of these steps, we created a fully automated processing pipeline, which is therefore able to measure the flow of code from Stack Overflow into Google Play. So let's apply this processing pipeline on Stack Overflow. The first thing we have to do is get all the Android-related code snippets, and this is quite simple by just filtering the Android tag. And after that, we want to obtain the security code snippets from our first set. And for this, we define a code snippet as security-related if it makes use of a Java security API. And with this definition, we can ensure that we cover all the security categories that have been prevalent in related work, meaning TLS, cryptography, and so on. Of course, this is not a comprehensive set of code snippets that might affect application security, as there can be code snippets that don't make use of security APIs but still affect application security. So now that we have those security-related code snippets, we want to know if they're secure or insecure. And our first approach for this was just manually reviewing 1,500 security-related code snippets, scoring them as secure or insecure, which we did based on the categories, security category specific parameters. And so we used this approach for our first submission of this paper to NDSS, and unfortunately it got rejected. So the reason for this was they wanted an automated approach for security analysis. And luckily, during that time, I got a new colleague, and he told me we can do this using supervised machine learning, as we already had an annotated data set of security-related code snippets we can use to train the support vector machine, which is then able to classify the code snippets as secure or insecure. And we did this. And so in the last step, we want to detect the code snippets in Android applications. And for this, we use the PDG-based clone detection, which is state-of-the-art for detecting clones created by Copy&Paste. And at that, it has certain robustness features that were useful for our use case. For example, it is robust against semantically similar but independently developed code and against slight modification that can occur when integrating the code snippet. So now let's have a look at the results of our processing pipeline. So from the 30 million posts available on Stack Overflow, we obtained 2 million Android-related posts, and a little bit more than 60% of these posts contained a code snippet. And from this code snippet, we only obtained 4,000 security-related code snippets. So first, let's have a look at the training set. Here you can easily see that TLS and symmetric cryptography are those categories that have the most insecure code snippets. And this already shows an indication that there is a correlation to the security issues I was presenting during the introduction. So, but on the other side, we also have a lot of secure codes on Stack Overflow, for instance, for signatures or message digests. So we use this train set to train the SVM to be then able to classify the whole set of security-related code snippets on Stack Overflow. And in the end, this resulted into 17% of secure code snippets and 30% insecure code snippets on Stack Overflow. All right, so now that we have the secure snippets and the insecure code snippets, we want to know what kind of code snippets are copied and pasted the most into Android applications. And to do this, we downloaded 1.3 million apps, which basically make all free apps available on Google Play. So we found 200,000 apps that contained a security-related code snippet from Stack Overflow. This makes 15.4% of apps available on Google Play. And we found a little bit more than 17,000 apps that contained a secure code snippet. But unfortunately, we found almost 200,000 apps that contained an insecure code snippet from Stack Overflow. So this means that 98% of the apps we found with a security-related code snippet from Stack Overflow contain at least one insecure code snippet. So let's have a deeper look at the top offending snippets. And the winner was the TLS snippet, which we have found in 180,000 apps. And the snippet basically deactivates server verification, which makes it vulnerable to man-in-the-middle attacks. And as already shown in related work, this poses high risk of exploitation in the wild. The second most prevalent code snippet was an AES code snippet that we found in 18,000 apps, which makes use of ECB mode and is vulnerable to chosen plaintext attacks. And at that, we found a couple of apps that contained a code snippet with hard-coded cryptographic keys which can lead to key leakage when reverse engineering apps. So now that we know the insecure code snippets from Stack Overflow that are copy and pasted into Android apps, we wanted to have a look at the community feedback provided on Stack Overflow for these insecure code snippets to see if the feedback is contributing to copy and paste insecure code or preventing it. And when you look at code snippets that are provided as an answer, meaning that meaning that it provides a solution to a stated problem, you would expect a lower score for insecure code snippets than for secure code snippets, as it does not provide a useful answer from a purely security perspective. And this was the case in Stack Overflow. But when you now include a warning, meaning that we were looking at code snippets, insecure code snippets, which had a comment that explicitly stated the code snippet as insecure, we unfortunately observed the opposite. So this means that the currently deployed feedback system on Stack Overflow is not sufficient for providing a precise security estimation. So, and next, we had a look on the impact on copy and paste. And for this, we first had a look at the view count and the score of code snippets. And for this, we expected a positive correlation with copy and paste, meaning that the higher the view count, the higher the score, the higher the copy paste rate of the snippet. And for this, and this was also true. But again, when we had a look at code snippets that also had a security warning, we have the opposite behavior again. And as a striking example for this, we have our top offending TLS snippet we found in 180,000 apps, which has been commended with several warnings. So this looks like that warnings that explicitly state code snippets as insecure are simply overlooked or have been posted lately and therefore did not affect the users yet. So what are the takeaways? We now have an answer to the initially posted question, as we now know that 15% of Google Play contain an insecure code snippet from Stack Overflow. But also on the other side, we have a distribution of a significant amount of secure code. So what we have to do is to prevent the flow of insecure code and reinforce the code of secure code. And as possible future work for this, we see an improvement of Stack Overflow with an alternative web interface that is more security focused. And we can use our real-time classification to provide visual security indicators. And at that, we need a more security-focused feedback system. All right, so thanks for listening, and we open source all data on our webpage. And now I'm happy to take questions.
We have time for questions, so well, I think Dave, you are first. So.
Okay. Hi, Dave Levin, University of Maryland. So I long thought it'd be kind of a cool attack to just intentionally post malicious code on Stack Overflow and then just wait for somebody to copy paste it. It's interesting that this is happening. I'm curious if you've given any thought to how you might go about evaluating whether or not this was sort of negligence or malfeasance. So, I mean, one avenue to that maybe would be to look at who has been posting this stuff. Have you looked at like any commonality amongst the folks posting these insecure things on Stack Overflow?
So first of all, we didn't analyze this, but of course we also had the idea of this. There's a term called crowd turfing, which is used for crowdsourced services where the community is just contributing badly And we also thought maybe this for Stack Overflow, you can do something similar by just planting a lot of insecure codes or planting backdoors or whatever to maybe use this for an attack. That's, of course, it's an interesting thought and could be a nice future work, yes.
Saurabh Bakshi from Purdue. You had as one of your filtering steps security-related code snippets.
Yeah.
Now, there are code snippets which are not explicitly related to security, such as how component interactions are done through intents, for example, which can have security implications. So the fact that you are filtering those away, does that bias your result?
Yeah, as I already said, this OS set of security-related code snippets is not comprehensive. This is, of course, this is a case where you use an API. What you told is a case where you use an API which is not a security API, but which can also lead to vulnerabilities. So in the end, of course, it influences our results. But if we can include this, the results maybe even get worse. So this is also future work to look at other categories of security-related code and see what is the impact.
I actually have a follow-on question on that. So when you apply machine learning classifiers, one of the known problems is that they are a black box. So they say something is secure, something is not secure, but you don't know why, right? So how can you be sure that your classifier is actually making the right determinations?
For this, I would like to ask my colleague to answer this question. He was the machine learning guy.
We're totally aware of the problem of black box machine learning. So in order to maybe explain this classifier in depth, I think we apply SVM as the features are completely texture-based. So we're basically looking at their vocabularies, the tokens, within this code snippets. So somehow this term frequencies can explain the security-related informations. But if we want to have a deeper look at why these code snippets indicate the security levels, I think we need to apply some other machine learning models. And this is a common sense in the machine learning community is we need some more model transparencies. So currently, I only see the possibility if we apply a probabilistic graphic model or some other causality discovery algorithm which can maybe explain the machine learning model a little bit more in depth. But mostly, deep learning, deep neural network, this kind of a discriminative classifier can only tell you whether it is secure or insecure.
We have time for a couple of more questions, and please, the next speaker is set up in the meantime.
Tobias Fiebig, TU Berlin. I was wondering, wouldn't be like, I know it's a bad word, but censoring those security-sensitive bad answers on Stack Overflow makes things better. So if they're commented and marked as like, this is bad, don't do this, it apparently doesn't help. So like redacting them.
You mean deleting them, or?
Yes.
The code snippets?
Well, the Stack Overflow threads.
This is another good question, because the top offending snippet, the TLS snippet, this snippet was needed because the security API wasn't helpful for a specific use case, meaning using self-signed certificates. And because the API wasn't providing this, users needed a workaround. So that's why this code snippet was distributing so much, and was you can find a lot of copies of this on Stack Overflow. So I think when we just have deleted this code snippet, it could also I'm not sure if it helped, because the security API was still not offering the feature for using self-signed certificates in a secure way. So that's why that's why Google replied to this problem and changed the API to be able to use custom trust managers and self-signed certificates in a secure way. And now I'm expecting that these code snippets are going away. So I think only deleting this code snippet wouldn't result into I would think that it would have popped up somewhere else. So if the problem is so severe, like in this case, you can just killing it on Stack Overflow might not have been the definite solution to this. So in the end, this is another aspect which I think is quite interesting. So what you could do is just auditing Stack Overflow to see what are the problems developers have. In this case, if we would have audited Stack Overflow earlier, we would have detected the problem they have with this API, and maybe the API could have been modified earlier.
So unfortunately, it looks like we're out of time, so maybe we can take the rest of the questions offline. Let's thank the speaker again.